Today we're doing U-substitution with definite integrals. I'm going to walk you through a method. Now, the words "can't you just" are probably going to come out of some of your mouths throughout this lesson, and the answers are probably going to be yes and no. But just stay with me, and then I'll answer all the "can't you justs" at the end. Yeah, we're jumping right in with an example. I'm going to teach you in the context of a problem. So you have the integral from 1 to 2 of 2x times x squared minus 2 quantity cubed. All right, so the first thing that we have to do when we have, this is just like in all the U-substitution problems you did a couple days ago, except now we have limits, right? So first thing we're going to do is we still have to go ahead and do the U-substitution. So I want everyone to take a minute. Don't put in any limits yet, but see if you can figure out the equivalent integral for this using that U-substitution. Alright, so what's u?
X squared minus 2.
Good. So what's du?
2x dx.
2x dx. Oh, isn't that nice? That's exactly what we have, right?
So nice.
Oh, it's so good. Okay, so what we have here is just u cubed, right? This is u cubed, and then 2x dx, that's just equal to du. So this is just the integral of u cubed du. Now, here's the thing. These limits, if you were to plug these numbers into this function, these limits are x values. This is actually the integral from x equals 1 to x equals 2. If we write the function in terms of u, we have to modify the limits so that the limits are u values. You want the limits to represent the same variable as the variable here in the integrand. So if you have x's here, these should be x values. If you have u's here, these should be u values. So what do we have to do? Well, we got to find u. So if x is 1, how could I figure out what the equivalent u value would be?
Plug it into...
You plug it in right here, right? So if x is 1, u is 1 minus 2, or negative 1. For our upper limit, if x is 2, u is 2 squared minus 2, which is 2. It just happens to be the same. You have to be able to change your limits appropriately. The College Board does ask questions from time to time where it'll give you the original function, it'll look like this, and then it'll give you this, and it'll say, you know, what would be the correct values for the limits, right? So they want to know that you know how to do this. So make sure you know how to do it. Okay, so we've got that. Now let's go ahead and find the antiderivative. What's the antiderivative of u cubed?
U to the 4th times
1/4 u to the 4th.
1/4 u to the 4th.
That took way too much.
Yeah. From negative 1 to 2. Now, this integral equals this integral, which equals this. You don't have to convert back to x's. You could just keep it like this, and my advice to you is please do keep it like this, and go ahead and just plug in the values for u, Because if you do convert back to the x function, what's going to happen is you're actually going to have a more complicated thing to plug values into, and you have to convert the limits back. So keep your function u and just plug in the numbers right there. So we have 1/4 times 2 to the 4th minus negative 1 to the 4th, so we end up with 15/4. And you're done. If you were to convert this function back to x's, you would have to convert the limits back to the x limits. So then there's no reason to. So when you're doing a definite integral and you do your U-substitution, keep it with u and just plug the numbers in. Don't even substitute back. It's just faster. It's faster and it's easier. Okay? I always have students who don't want to convert the limits, and so what they do is they do the U-substitution and they'll write this out, and then they'll just like not put the new limits, and then they'll convert, and then they'll convert back. I will take off because this doesn't equal this, right? So as soon as you lie to me, you lose points. So yeah, no lying. You got to convert the limits. I want to see that you know how. But the biggest thing you want to be careful about, the most common mistakes on this, are either not converting the limits and plugging in x values for u, or converting the u back to an x but not converting the limits back and plugging in u limits for x. So you got to make sure if you have x's, you plug in x values. If you have u's, you plug in u values. You just need them to match, right? You'll get the right answer as long as the variables match. All right, let's try a slightly harder one. We did not have a good chance to really do a good special case U-substitution yesterday, so thought it'd be fun to do one today with definite integrals. So we have a nice special case U-substitution problem here. So for everyone, what's u? 2x minus 1. Everyone write u and du. All right, everyone good so far? No questions? All right, let's rewrite. This right here, this term is the same as u to what power?
Negative 1/2.
Negative 1/2, right? So that term right there, that's u to the negative 1/2. So we got that. Dx, well, there's no 2, so I'm going to divide out the 2. So dx is equal to 1/2 du. So I'm going to replace my dx with 1/2 du. Have I replaced everything in the original integral?
Still the x.
There's an x there. What am I gonna do about the x?
U plus 1 divided by 2.
Ah, okay, so to replace this x, I'm gonna have to solve for x here. So I add 1, so I get 2x equals u plus 1. So x is 1/2 times the quantity u plus 1. Or u plus 1 over 2. So I'm going to plug it in like this. 1/2 times u plus 1 du. All right, so there's a lovely integrand. We're not quite done cleaning it up, but we do have to write our limits. All right, everyone take a second and find the new limits.
Why wouldn't you include the 2?
Why would I not include the 2?
Include u plus 1. Okay.
Oh, I did.
Yeah,
I wrote it as a half. Alright, so let's see. If x is 1, hey, look at that. U is 1.
And then 9.
If x is 5, U is
9.
9. Ever get 1 to 9?
Yep.
Good. Alright, so let's clean up the integrand. So we have the integral from 1 to 9. I'm going to call this 1/4 times u to the negative 1/2 times u plus 1. So we get u to the 1/2 plus u to the negative 1/2. Make sure you multiply it out, right? No u's times u's, no products in your integrand. Alright, so we have 1/4, I'm just going to keep that out front, times. Alright, everyone find the antiderivative.
Can you take the antiderivative if you're multiplying, put by 1/4?
If you the 1/4 is a coefficient, yeah, that's fine.
So coefficient.
Numbers are fine.
But
Yes, scalars are
variables,
fine. Yeah, variables, no. Scalars, numbers, you can multiply all the coefficients you want. Everyone okay?
Swag money.
Swag money. All right. Okay, so now we have to plug in a 9. We are not allowed a calculator for this problem, so here's my question to you. 9 to the 3/2. Should I do the power or the root first?
To the power.
So do the power. So find 9 cubed, and then find the square root of 9 cubed.
Yes.
Now,
Alright.
why would you do the root first?
Easy.
When you do the root first,
I want
it
a
keeps
challenge. I
the
want to
numbers
keep my brain
small.
working.
You want to do see who can do it faster right now?
All right. Okay.
Ready? Go.
What's 9 times 8?
You wanna take the antiderivative?
All right. I give up.
Okay, good. All right, so here we go. When you plug in, you have 9 to the 3/2. 3 means that's the power, 2 is the root. Do the square root first, which is 3, and then cube it, right? 27. Much faster than doing 9 cubed and then having to figure out that square root. All right, so you get 27. All right, plus 2 times, what's 9 to the 1/2? 3, minus the quantity 2/3 plus 2. Alright, it's fun with fractions. Okay, so 2/3 of 27, that's 18, plus 6, minus 2/3, minus 2. So we end up with 24, 22, 21 and a third, which is 63, 64 thirds. So we end up with, when you divide by 4, so you get 16/3. Okay. Alright, now the only new thing that we learned, this is stuff you could have done before. The only new thing we learned was how to change the limits, right? And just remember, once you do your antiderivative, don't go back to x, stay with u, plug the numbers in. Alright. Okay. The last topic for this unit is to learn about integrals of odd and even functions.
I'm so excited.
I know.
But I just can't hide it. It's like my favorite time of the day. Math class.
Oh, you know, it really should be everyone's favorite time of day.
I'm just
right?
kidding. It's like my second favorite time of the day. I really do enjoy the time that I'm in my bed.
Oh. All right.
My bed is just so warm. Like, honestly. If I could never leave my bed, I would.
Eat jelly beans and sit in bed.
Yeah, eat jelly beans, sit in my bed, and watch Netflix. I've been watching Criminal Minds recently. I'm already on season 4.
So, an even function has what type of symmetry?
Even. Origin. No, x-axis. Y-axis.
Why?
Y-axis.
Yeah, well.
Which type of symmetry does an even function have? Do you all agree?
Yes.
Y-axis. All right. An even function has y-axis symmetry, right? So whatever's on this side is mirrored on this side. What that means is if I want the integral from negative a to a, the same point on the other side of the y-axis, well, I could just find the integral from 0 to a and
Multiply by 2.
double it, right?
So then when would it equal 0?
It doesn't.
Not like when you sum together your areas. Okay, because
It's
like,
only if one of them is on the.
If part of it's below the x-axis and part's above, and that, I mean, then you could get 0.
okay, I'm just being stupid.
Yeah. But there's no rule about it for even
I'm just making
functions.
stupid.
Okay.
Being.
So, yeah, if you have the integral from negative a to a of f of x dx, and it's an even function, you can find the integral from 0 to a and double it. Okay. For an odd function,
Oh, that was fast.
yeah, we haven't done an example yet.
Oh.
Odd functions have what type of symmetry?
Origin.
Very good.
Close.
Okay.
Just
Close
shut
round.
up, shut up.
Alright. Odd functions have origin symmetry. And because of that, anything that's below the x-axis on one side is above the x-axis on the other
I think you
side.
spelled Oregon. How do you spell origin?
O-R-I-G-I-N.
O-R-I-G-I-N. Oh yeah, I spelled Oregon.
Ah, okay.
It's the state.
Okay. So, if you are going from negative a to a, and you want the integral of an odd function, Rayan, what do you think that integral would be?
I don't want to
Zero.
hear this.
You could do it.
0.
0.
It is 0.
Thank God.
It is 0. That might have been what you were thinking of.
Yeah.
Okay. And it's because everything that's negative on this side is positive on this side, so they cancel each other out. Okay. So first example.
Oh my God.
So,
You honestly can you
Suppose-
right?
the integral from 0 to 3
Literally the ugliest handwriting you've ever seen.
of g of x dx is 2. And the integral from negative 4 to negative 3 of g of x dx is 4. Find the integral from negative 4 to 3 of g of x dx if g of x is even. Alright, so if g of x is even, now there's a method for doing this that I use. You can, this is not a requirement, this is just how my brain processes these problems. So what I do to make it easier for me is I make a quick number line. And I just put all the limits on there. So negative 4, negative 3, 0, 3. I always go negative to positive, even though I know 4 isn't one of the limits, but I just always write the whole thing. Alright, so I include all the negatives and positives of all the limits. And then I fill in with all the integral values I know. So I know the integral from 0 to 3 is 2. And I know the integral from negative 4 to negative 3 is 4.
Whoa, did we already have it all?
So, could we from that,
Assume that negative 3 to 0 is 2.
are we assuming or do we know? the
We're
integral?
supposing.
It's
We're
even.
supposing.
We know
No.
that the integral from, if g of x is even, then the integral from negative 3 to 0 has to be 2, right? Has to be 2 because it's got to be mirrored on both sides of the y-axis.
Don't be judging me.
Okay, so
There's a lot of judgment coming. You're already writing this down, Jacob.
So the integral from negative 4 to 3 of g of x would be what?
8. No, 8. What? 4. Negative 4 to 3. That's definitely 8.
Do y'all agree?
I agree.
It's definitely 8. Yeah. You guys made me
This
think I
is
was
4
insane.
plus 2 plus 2.
Or it's 4 plus 4 if you add up the 2's.
It could be that as well.
Or 4 plus
6
6.
plus 2.
No, that would
Oh,
not
6
be.
plus
That'd be
2.
2.
Or it's 4 plus 2 plus 2 plus 0.
Oh,
Or
that's
it's
a
20
good one,
minus 12.
too. Okay, so anyway, letter B. Suppose g of x is odd. So we have the exact same information given, but now we need to find the integral from negative 4 to 3 if g of x is an odd function. Tell me something that we could conclude about the integral from negative 3 to 0. It's negative 2. It's going to be the opposite of the integral from 0 to 3. So if g of x is odd, O for odd, O for origin, O for opposite, right? Oh, this
Oh,
is
for olives.
negative 2.
Do you know the olive theory from the Big Bang Theory? Or not from How I Met Your Mother?
No.
It's like if one person likes olives and the other person doesn't like olives, then you're destined to be together. Because like then you like fulfill each other's purpose. Like they don't eat olives and then you eat their olives. It's kind of like you, like if you don't like peppermint and they like peppermint.
I don't like Brussels sprouts, but my husband likes Brussels sprouts.
Exactly, that's like the olive theory. Except
But we
for,
both like olives.
Oh well, then you're not gonna like. Sorry to break it to you right now.
All right. That's just 15 years wasted. Okay, so here we go. So when you have an odd function, if you have an integral on one side that's positive 2, then the same corresponding integral on the other side of the y-axis would be the opposite, or negative 2. So what would the integral from negative 4 to 3 be for this one? This would be 4. Does everyone understand that? All right. We're going to take it up one quick notch and then we're done. This is the last example for the entire unit.
Before you erase the top stuff.
Yes?
So if it gives you that the integral from negative 4 to negative 3 is equal to 4, and then it says that it's odd, you can't change the sign of the 4.
Why is the
It stays positive.
You can't say,
You have to assume that it's above the x-axis.
well, you don't know if it's above or below, but the net of this integral is 4. Yeah, it's positive 4. So there has to be more above than below if it's positive integral.
That's why like it's not made like halfway through.
Okay. Oh, I gotta erase this too. Alright, so last example. Suppose.
Neither.
So we're gonna do.
I like your shirt made-up.
She's embracing stuff now.
Yeah, it's very great.
New example.
Her
So
grade is always
suppose the integral from 3 to 6 is 7, and the integral from negative 6 to 3 is 12. Find the integral from 0 to 6 if g of x is even. I want you to work on this in your groups for a minute. See if you can figure it out.
Oh, Jacob, I'm sorry.
Okay, you have the integral from 3 to 6 is 7.
Can you do that in
And the
your head?
integral from negative 6 to 3 is 12. See if you can figure out the integral from 0 to 6.
Jacob does the entire work. The group suffers, Jacob. The group suffers. Well, 0 is going to be in the middle, obviously. And then negative 6.
Should we put a 0 there?
And then I guess we could do 3 and
0 on
negative
my
3.
timeline.
Alright, you guys are pretty smart. Alright, so from negative 6 to 3, that's 12. Alright, we'll put the giant 12 there. And then from 6 to 3, that's 7. We'll put the giant 7 there.
What?
So from 0 to
That's
6,
7.
ooh, snap.
That's 7.
No, snap, that's weird. Alright, so what's 12 minus 7? 5. So then we can say that this is 5, the middle part is 5. So then what's 5 plus 7?
No, 12 minus 7.
12. That doesn't make any sense. So this is 7. This part is 7. This is negative 7.
No, what I'm saying is,
So this is 7. Then what is this? Has to be 5.
yes, so that means,
Yeah, that's what
what I'm saying is,
Do we know?
until it's like,
We don't know what.
that means negative 5.
Not, you don't know the
Zero to
but
7, 0 to 12.
you do know one thing about
That answer.
If it's 7 plus 12 minus 7 is 5, and you have divided
There's
by
like no
2.
math. It's just like
5 divided by 2.
It's the net. That could be like negative 30, and that could be like positive 35.
does that make sense?
Wait, what?
It's saying like all of that equals 12.
No,
And
that's
even then 3 to 6 positive
That's
is the
five.
same as negative.
No, then this entire thing right here equals 12.
there.
Does that make sense?
That's 2.5.
So that entire thing.
Anyone solve it?
I'm right.
One person, 2 people,
I got it.
3, 4, 5,
They're trying
6,
to tell
7,
me I'm
8.
wrong, but I know I'm right.
Everybody did.
Okay, 9. I saw
Alright,
9.
well, we figured out that the negative 6 to negative 3 has to be 7.
Ah, very good. Okay, so our first little clue towards solving is that the integral from negative 6 to negative 3 has to be 7 because it's an even function.
And then
right?
from negative 3 to 6 is also 12.
Okay, yeah, that works. What about from negative 3 to 3 then? What is the integral from negative 3 to 3 have to be? Has to be 5. And because this is even, what do each of these have to be?
2.5.
2.5,
Are you
right?
kidding me, Jacob? We literally told Jacob that, and he's like, no, that's not possible. He was like, one of them could be like negative 30, and the other could be like 35.
Not on an even function. Yeah.
This is why you write things down.
So, okay.
So
Yeah, even function, you have to have a mirror image on both sides. So what is our integral from 0 to 6? 9.5.
See, we could have gotten that before his group.
Okay. That's it for, we're going to just talk a little bit about that, but I'm going to shut off the camera.